Hello programmers, welcome to FindStack. Today we are going to create one application using multi-agent framework. The application is all about data visualization. Basically it will take one Excel file as an input and it will generate diagrams out of it. Before we code the application, let me show you what I have in my head. I'll show you here. My architecture diagram. As you can see, we are going to take one Excel file as an input that we are going to feed to the metadata generator. The metadata generator will be an agent. The agent will generate information, columns, description, head, all this information about the Excel file that we have given. I'm pretty sure that something is clicking on your head, that all these things are built-in pandas function. So we are going to use those to generate information, columns, description and head of the Excel file. Now all this information will be fed to the required plot idea generator. Again, it is one of the agent that we are going to create. The purpose of this agent is to generate the plot names that we are going to finally create. Now the plot names along with the metadata will be fed to the coder. The coder will obviously write the Python code or Python script that can be used to generate the diagrams. At the end of the diagram, we have the code executor. The code executor will just execute the code and will finally have the diagrams. I hope that it is making some sense to you. If not, let me just code it. I hope after that it will make sense. So this is our project files. We have the .env file where I have my OpenAI keys. Of course you need LLMs. Of course you need to pay for that. I am not going to pay for your API calls. No, not going to happen. So I'll keep that secret. Apart from that, we'll have breast cancer dataset, which I have taken from Kaggle. Same goes for the Titanic dataset. I have again taken it from the Kaggle website. I will put the links in the description. We have this pip file as well, where I have mentioned all the requirements, all the libraries that we need for our application. Let me go ahead and install it. Okay, so it has been completed. Okay, let me code the application. You know what? LLM is the base of any multi-agent application. So let me create the instance first. Okay, I have created the LLM instance. Now you might ask, why did I set the temperature to 0.25? To answer that, I have to say that I have already created the application and I have it ready here in this monitor. I am just copying it. Now when I was creating the application, I found that having a lower temperature was helpful at the coding part or making the decision consistently part. It will just remove the randomness out of the application. So that is the reason I have set the temperature to 0.25. I could have gone a little bit lower than that, but this is what I found to be working. Now, what else do we need for a multi-agent application? The messages state. Let me import that. Now this messages state can store all the messages that we have sent, or basically whatever we want to store, those messages it can save. But I also want to store the Excel path so that it will be very easy for me to reference it later. That is why I want to modify the message state a little bit. Let me do that. Now this is what we have done. We have created one separate class that is having the same name called message state, but of course you can give a different name. I chose to give the same name because why not? I have set the parent class as the message state that we have imported from LangGraph.graph, and then we have added one more property to the class that is called Excel path, where we are going to store the Excel path. Of course. Now we need the functions that can generate the metadata. These ones: information, columns, description, and head. Now I could write all these functions manually, or I can copy. What is the better option? I think copying is the better option because I do not want to flex. I do not want to flex my typing skills. Let me just copy. That is it. Look, I have written all these functions with proper documentation. I mean the doc strings. Just keep it in mind that these doc strings are important when you are creating a multi-agent framework application or any kind of agentic application. These doc strings are important, so do not forget about the doc strings. Also, do not forget to mention the types. Type hinting is also very important in any kind of agentic application. Here we have created the columns which will return the columns. Same goes for information, description, and head. Now as we have all these functions, but our LLM still does not know about all these functions. How can we tell the LLM that these functions exist so that LLM can use those? To do that, we have to call the bind tools function like this. If we call the bind tools function in our LLM and will pass the functions in a list, then it will return a new LLM which has the information about these functions. This LLM basically has the knowledge that these functions exist in our system. Right? Now let me go forward and create one agent. Now you tell me, what was the first agent? I'll give you 3 seconds. Sorry, I do not have time. The first agent was the metadata generator. Let me create that. This is our metadata generator. Let me do a word wrap. Right. Now, what is an agent? That I have to define first, right? An agent is nothing but a function which has a system message like this. You will be given an Excel file path. Your task is to generate the columns, information, description, and head of the Excel file. Now the agent should be able to invoke one LLM like this, like we are doing here. LLM with tools, we are invoking. the agent should be able to store the messages or the responses to a state. Here we have the messages state. Now finally the agent should be able to call a different agent or end the application. That is it. That is the entire application. That is the entire journey of an agent. Now here in this case I have already shown you the system message. Now let me go ahead and create the other two agents. Here we have our required plot idea generator. Again, you can read the system message. I am not going to read it to save some time. And we have finally the coder. Now you might ask, where is the code executor? To answer this, you just have to know that I'm very lazy. I did not create it. I just created the coder and the coder was able to create the codes. Then I thought, I can execute the code myself, right? So why bother? Well, I can write the diagrams. I can write a script to generate the diagrams as well, but I thought executing a piece of code is a piece of cake for me. So that's why I have not created the code executor, and that is a future scope maybe for this application. We'll see. Now, finally, the juicy part. We are going to create the connections. First of all, we need to create one builder. Let me just go ahead and import all the necessary modules or functions. We need to add the nodes. The first node, of course, will be the metadata generator. Here the node refers to individual agents. So the first agent is metadata generator. Now we have one special node called the tool node. The tool node, as the name suggests, is basically one agent which can execute the tools or the functions that we have mentioned. Now let me add the final two agents, that is the required plot generator or the required plot idea generator and the coder. Now, having all these agents is not sufficient. We need to tell that first we need to call the metadata generator, then we need to call the tools node, then we need to call the required plot idea generator, then we need to call the coder. These connections we have to make. Let me make the connections. Here we have the connections. As you can see, we have added one edge from the start to the metadata generator. So after we start, the first agent that will be called will always be the metadata generator. Now the metadata generator, as you know, must execute 4 tools. So we have added the edge between metadata generator and the tools node. After generating the metadata, we need to call the required plot idea generator to generate the plots. After we have generated the plots, we need to code it. So we have made one connection from the required metadata generator to the coder, and finally we have made one connection to the end node. End node suggests that It is ended, it is gone, it is finished. Now let us compile the graph. Let me show you one cool thing, okay? This is very interesting. If you use this function display image graph get graph blah blah blah, you can print out the graph that we have created. If I put the image side by side, then you will see that it is very similar. We have the metadata generator, we have the tools. These are the tools. Basically, these are the pandas functions that we have created. I mean that we have extended. After that we have the required plot idea generator, then we have the coder, and then that is it, because we have not created the code executor. Now let me demonstrate the application to you. Let me invoke the graph using the Titanic dataset file. Let it do its job. Okay, now it is working. Let it finish. Okay, the result has been stored in the result variable. Let me print the last message. Now why am I printing the last message, you may ask? Because last message is basically the response of coder, and that is what we are interested in. We are not interested in the previous conversation. That is why we are taking the last message, and content of course is the message content. Okay, so this is our final code that has been generated by the multi-agent framework. Let me execute it. Okay, as you can see, it is reading the Excel from Titanic dataset XLSX, which we have here. So we should not face any problem regarding reading the file. It is trying to generate 8 plots. Let it generate the plots, then we'll see. Okay, here we go. It has generated the distribution of age, and it has generated the fare distribution by passenger class. It has generated the survival count by sex. Here you can see that females has survived more than the males, which is not, I'm not happy, I'm scared, I'm not going into the Titanic. Okay, now we'll generate the breast cancer dataset diagrams. Okay, here we have the code to generate the diagrams out of the breast cancer dataset. Let's examine it. Let me just execute it, and we'll see if the dataset or the diagrams make sense. Again, here you can see it is importing or reading the Excel from proper path. So path related issues we should not face. Okay, it has generated some diagrams: distribution of radius mean, area mean by diagnosis, some plots, I am not sure, and that was it. Although I am not totally sure about the helpfulness of these diagrams, maybe you can tell. I am not an expert. Anyways, as you can see, it was able to generate some diagrams. You can improve it by tweaking with the prompts. You can improve it by, let's say, adding some more agents. And finally, remember that, guys, an AI is not a replacement of a professional. All of these that are being generated, of course, has to be verified by a professional, and If required, we need to generate or we need to write some code to create more diagrams. That is it for today's video. I hope that you liked it. If you have any kind of suggestion for our upcoming videos, please leave a comment. For example, my here and there daddy jokes. If you like this video, there is a like button. If you dislike the video, then there is a dislike button. And finally, subscribe to this channel so you'll not miss the upcoming videos. Thank you.